Hello everyone, this is lesson 5, reflections in the x and y axis. So we're going to start off with just reviewing of the coordinate plane. So the Cartesian coordinate system is created by the intersection of two number lines. The horizontal axis is called the x-axis and the vertical axis is called the y-axis. So here we've got the x-axis and we've got the y-axis going vertically. Now, if you just think about a number line starts at 0, and it's going to go positively to the right. And you've got your negative numbers going to the left. Well, the y-axis works like a number line, but just vertically. So again, you have 0 right there, and then you have positive numbers going up, and you've got negative numbers going down. Now, the center point, 0, 0, where it's 0 on the x-axis and 0 on the y-axis, this is called the origin. Okay, the origin. And you're going to need to know that. So if someone says, where's the origin? Well, it's the intersection of the x and y axis. So every point has x and y values called coordinates. The coordinates are displayed as an ordered pair. In an ordered pair, the x coordinate is always listed first, and the y coordinate is always listed second. Okay? This is just so that anybody reading the graph will be able to know what you're talking about. So let's try a couple examples here. So A is right here, and we got to figure out what are the coordinates. So if you're to draw or highlight, that's where they intersect. So the x coordinate is 2, and the y coordinate is 6. So you would write 2 and 6. B, first find B, and there it is. So its y coordinate is 0, and its x coordinate is 4. Let's find C. So there's C. First, let's look at the x coordinate. So it's right at -5, and the y coordinate is -7. D, its x coordinate is 3, and its y coordinate is -3. Now I want you to pause the video, try E, F, G, and H, and then click play and see if you get it. So E is going to be at -3 and 2, F is at 0, -2, G is at 6, -6, and H is -6 and 6. So it is always the x coordinate, then the y coordinate. So let's plot these points on the grid. I'll do a couple, and then you need to pause the video and try some for yourself. So A is at -4, 3. So you start at the origin, and you're going to count to -4 on the x-axis. Now remembering that these are x, then y. So let's count to -4 on the x-axis. So 1, 2, 3, -4. And then we're going to go to 3 on the y-axis. So we've got to go up. 1, 2, 3. So there it is. And you wouldn't include all that stuff, just the point. And you'll label this A. Okay, let's find B. Well, B is 0 on the x-axis and -3 on the y-axis. So we don't actually have to go left or right. We're just going to go down to -3, and we'll call that B. C is at -3 on the x-axis, so let's go to -3 on the x-axis. And then it's at 0 on the y-axis, so we don't have to go up or down at all. So we just put a dot there, and we'll call that C. D is at -3, -4, so -3 on the x-axis, and -4 on the y-axis. And see where they intersect. There it is. Try and get rid of that highlighting. There we go. and that's point D. E is at 6, 7, so you're going to go to 6 on the x-axis. It's going to be somewhere there, and 7 on the y-axis. So it's going to be up where they intersect. And we'll call that point E. All right, here's where I want you to pause the video, try F, G, and H, then click play, and see if you got it. So here's F. G is at 0, 0. And what do we call that? It's the origin. And the last one, H, is at -6, 5. There we go. All right, when you stand in front of a mirror, you see an image of yourself, your reflection. If you move closer to the mirror, your image moves closer. If you move back, your image moves back. Your image is always the same distance away from the mirror as you are. In mathematics, a reflection is a transformation in which a figure is flipped over a mirror line or reflection line. So in what ways are an object and its reflected image alike? Well, it's the same size, and it has the same shape. And what are they different? Well, they have opposite orientation. All right, so here's what we need to do. Pause the video. Well, not just yet. Plot ABC, and that's triangle ABC with these coordinates, A, B, and C. So A is at 2, 5, B is at 2, 1, and C is at 5, 1. So plot those points, pause it, and then see how you do. So A is at 2, 5. B is at 2, 1. And C is at 5, 1. Okay, and then we're going to connect. Use a thicker pen here. Okay, so we're going to connect our points, A, B, and C. All right, and what are we doing here? We got to reflect it in the y-axis. So which one is the y-axis? Well, let's just highlight it. There it is. So how do we reflect it in the y-axis? Well, one way you could think about it is A is going to be the same distance away from the y-axis. So if we count 1, 2, do the same thing. Count 1, 2, and you'll put a dot. And we're going to call this A prime. Now you might be thinking, well, we used prime in the last lesson to represent sort of an enlargement or a reduction. Well, we're using the same symbol to represent something different. It's related to it, but it's something different. It's actually a scale model, just in a different orientation. So B, let's think about B. B is 2 away from the y-axis, so we count 2 more, and there's a point, and we'll call that B prime. Now C is going to be 1, 2, 3, 4, 5 away from the y-axis. So you can count 5 away on the other side. It's getting a little messy here. Let's try and clean this up. There we go. So counting 5 away from the y-axis, 1, 2, 3, 4, 5. We're going to put a dot right there. Oops, let's put it in red. And that's going to be C prime. So then we can go ahead and connect these points. And we'll get our reflected image in the y-axis. So let's talk about what the coordinates are of this different point. So A, that was at 2, 5, is now at -2, 5. Did the height change at all? No, it didn't. So the height doesn't change if you're flipping over the y-axis, and that makes sense because your object isn't moving up or down, it's only moving left or right. So only your x coordinates should change. So if thinking about that, what's the y coordinate of B? Well, it's 1. And because the height doesn't change, the y coordinate of B prime is also going to be 1. And B was 2 away from the y-axis, so then it becomes -2 away from the y-axis. C, its y-coordinate is 1, and its height didn't change, so its y-coordinate is still going to be 1. But its x-coordinate is going to be -5, and that makes sense because it's on the other side of the y-axis, 5 away. All right, plot points A, B, and C again. So pause the video and see how you do. So A is at 2, 5. B is at 2, 1. I feel like we've seen this one before. And C is at 5, 1. So B and C. Okay, you can shade it in if you like. So we've got A, B, and C, and we're going to reflect it over the x-axis. So the x-axis is the horizontal axis. So instead of counting, back to the y-axis, we're going to count down to the x-axis and then do the same thing on the other side of the x-axis. So A is at 5, so we're going to count 5 down. 1, 2, 3, 4, 5. And that's going to be A prime. B is 1 away from the x-axis, so it's 1 away on the other side. That's B prime. And C is also 1 away from the x-axis. And you can shade that in. So A prime, B prime, and C prime. So what do we notice about this? Well, because we're not moving left or right, the x-coordinates actually stay the same. So A is at 2, 5. So it's going to be at 2 and -5. B is at 2, 1, so it's going to be at 2, but -1. And C is at 5, 1, so it's going to be at 5 and -1. You'll notice that the y-coordinates all change because that makes sense. It's moving up or down. Well, it's being flipped over, but its height is changing. Okay, D, E, F. So plot these points. So pause the video, plot them, and see how you do. So D is at 2, 6. E is at 4, 1. And F is at 7, 4. And we'll connect those points. Okay. And we're going to reflect it in the x-axis. So pause the video, highlight the axis you're flipping it in. There we go. So in this example, the x-coordinates aren't going to change because it's not moving left or right. It's moving up or down, being flipped over. So the x-coordinates all stay exactly the same, 2, 4, and 7. And the y-coordinates are equal distance away from the x-axis, but they're going to be negative. So this is 6, and it's going to be -6. That's D prime. E prime is going to be at 4, but -1. And then F prime is going to be at 7, but at -4. And you can go ahead and connect those ones. So -1 and -4. All right, a quadrilateral has these 4 vertices, so pause the video, plot those points, and then click play and see how you do. So we've got A at 2, 1. 2, -1. So there's A. And then we've got B at 5, -1. We've got C at 6, 2. And D at 1, 2. So connect those points. Looking good so far. All right, that's job 1. The next one is draw the image reflect in the y-axis. So we're flipping it this way. And if you recall the y-axis, if you're flipping it in the y-axis, your height isn't changing, So your y coordinates are all actually going to stay the same, but your x coordinates are going to change. So let's start with D. That's probably the easiest one. I think it's closest to the y-axis. It's 1 away. So we just go 1 to the left of the y-axis and call that D prime. A is 2 away here. So you go 2 in the other direction, and you can put your A prime. Now B is on the same height as A, and it's 3 away, so 1, 2, 3, B prime. And then C is going to be right there, C prime. So connect these points, and there you go, a reflection in the y-axis. So again, your y coordinates are not going to change, so you can keep the y coordinates, which are all of these ones, the exact same. So -1, -1, 2, and 2. Now your x coordinates, they just become negative. So -2, -5, -6, and -1. All right, and that's it.